Hello everyone, I'm so happy to make the presentation here. The title of my paper is Fast Integration System of English Online Learning Resources based on Multi-Sensor Network. I'm Haiyun from Sanya Aviation and Tourism College. I will introduce my paper from the 4 parts: Introduction, Research Process, Research Results, and Conclusion. Now the first one, I will introduce my research background. So, as we know, network education is a promising new word of education. The core of network education is the network course, and the integration of network course resources play a basic and overall role in the quality of network education. However, the lack of efficient integration of network course resources is very prominent, which greatly reduces the efficiency and quality of network teaching and learning. For example, common English learning resources integration system cannot meet the needs of users through network environments because there's a throughput reduction phenomenon while the traffic load gradually increases. So, based on the above problems, a fast integration system of English online learning resources based on multi-sensor network is proposed in order to improve the efficiency of online education and the quality of online learning innovation process. Now, second, I'd like to introduce the research process. So generally speaking, the process will follow the 3 procedures. The first one, hardware design. The second one, software design. Third, system test. Now let's come to the hardware design. So in order to design hardware for the system, first we have to design the system hardware architecture. Based on the resources integration system designed by the previous researchers, the hardware architecture of the rapid integration system of English online learning resources is designed, as is shown in this figure. The second, in the rapid integration system of resources in multi-sensor network, each sensor node samples the English online learning resources according to its own sampling period, and then transmits the collected raw data to the estimator, which estimates according to the information transmitted by the sensor. Of course, a sensor node can not only transmit the status information of English online learning resources collected by itself, but also act as a routing node to help other sensor nodes transmit data. In this case, the sensor nodes does not do data processing only for acquisition and transmission. Now, the structure is shown in this figure. So, after the hardware design finished, now let's proceed into the software design. The first one, we will design the functional structure of the system. According to the overall structure of the designed English online learning resources integration system and based on the Open Archive Information System Model OAIS and Multi-Sensor Network. This paper put forward the functional structure of the Computer Network Teaching Resources Integration System. And second, we will determine the system function modular design, including the resource collection and submission module, resource storage and management module, resource release and service module. So after the soft and hardware design, we have finished the general construction of the system. Now we will put the system into test. So in order to verify the design of English online learning resources rapid integration system, two groups of common English online learning resources rapid integration systems are selected. The throughput, loss rates, force detection rates, and integration efficiency of the three groups of English online learning resources rapid integration systems are compared. Now let's look at the results of the experiments. The first group of experiments results. So you can see this figure, right? And it is clear. We can see that the throughput of the common system 2 is almost the same as that of the designed system when the traffic load is kept as 0 to 45 MB per second, but the traffic load increases to 50 MB per second and higher. The network throughput curve of the two common systems began to change gradually, showing a downward trend. It is proved that the original systems cannot keep normal operation and cannot meet the resource demand of users when the network traffic load is too large. However, the throughput curve of the designed system is stable, and it will not cause network congestion due to the increase of traffic load, and it can meet the need of users. Now the second group of experimental results. So we can see a table here. So from this table we can see that after the design system is used to integration the resources of the English online learning platform, the error detection rate and the loss rate of the resources are far lower than those of the two groups of commonly used systems. Among them, the error rate of the proposed system integration resources is only about 0.14%, while the number resources is 80,000. While the error rates of the other two resources are about 1.56% and 0.95% respectively. With the continuous increase of data, the error rates of the three methods have a rising trend, but the error rates of these methods is lower. Therefore, the integration success rate of the design system is higher and the system performance is better than the common systems. Now look at the third groups of experimental results. So from this figure, we can see that The design system takes the shortest time to integrate the digital resources, and with the growth of the number of resources, the overall rise of the time is relatively slow, and there is no phenomenon that the growth of the number of resources takes too long. However, the time of the other two groups of common systems grows faster when the number of resources is higher, indicating that the performance of the other two groups of common system is unstable. It is settled. Among them, the highest speed of resource integration in this paper is about 100 ms, while the highest speed of the other two systems is about 800 ms and 900 ms respectively. In contrast, the speed of the proposed method is faster. Therefore, the design system has higher integration efficiency and stable performance. So now we can come to the conclusion. The design of a rapid integration system of online learning resources based on multi-sensor network, which makes full use of the multi-sensor network, collects English online learning resources efficiently. The system test results show that design has practical significance for the improvement of data throughput. The application of the design system to the integration of the resources on the current online learning platform can effectively improve the data processing ability. For the suggestion of the further research, I'd like to say that in addition to continued improvement of the dynamic resource configuration and access interface, the integration degree should be increased through further research on integration mode and integration technology, so that the users can use network resources more conveniently and effectively. So that's all for my presentation. Thank you for your listening.